I do better the second time, so I'm going to record this. So in this proof guide, if you go back and look at the homework problem, I think I called it homework 1. Okay, so here it is. So they say prove for any two events A and B that the probability of this holds, right? So over here, as an if-then statement, if you write it, you'd put if A and B are events and P is a probability, it's suppressed in that statement, then probability A intersect B, I believe it was.
Complement B?
Yep. Is equal to probability of A
Minus probability of A.
plus or minus probability of A intersect B. Okay, so this part here, you try to make it as verbose as possible so that you can pull out as much as you can, because the more information you have there, the more puzzle pieces you have at your disposal.
Okay.
Right, so all of this part here is your no. Anything between the if and the then, that's your no. That's what you got. So that part here is your no. And so what you know is A and B are events, which is just they're subsets of the sample space, and you know that P is a probability. So you know those properties of probability. One is that P of C is greater or equal 0. And then less than 1, right? Sometimes I use that, so I'm going to put it in here. I think you guys saw me use that before. I'm not going to use the same letters, because if I use the same letters, it's incest. And then I have that other property that the probability of the whole space is 1. I might need that. We used it yesterday, actually. And the one that I use the most, though, is this one. And I don't write the infinite sum version. I write the little baby version. So I always like to say I like to manipulate the equations. Oops. Because that's what women do. They manipulate the equations. So where they don't have any common thing. I just write it with 2. The reason I write it with 2 is it's more useful for me. I can see it. Okay. Right? It's true infinitely. I keep that in my mind that it's true for an infinite set, but it doesn't look like I have infinite sets here, so I don't really worry about it. Right? So what do you have to show? That's all the words after the then. This part right here is your show. That's the last line you write in your proof.
Is it saying A intersect B? So the probability of A union B is equal to the probability of A plus probability of B, where A intersect B is the null set?
Yeah, they don't have any intersection, right? So then I have this down below, right? This is my show. So then comes the part that I think students find really hard, like how do I write the proof now? I've got this written out. And the answer is that you actually are looking at the no and show, which, oh, that's nice. This is what I have to show right here. And then saying, how do I put that together? And unfortunately, it's not on the same page. But I look at what I have to show, and I think to myself, I go back up to this no list, and I think, well, which one of these things do I have up here that looks most close like where I'm supposed to end up? What do you think?
The third.
Third one,
no.
right.
Yeah.
So then I think, well, how can I make this third one look like that thing at the end. That one's got a minus in it. And that my no has a plus. Okay, so I'm going to rearrange my show. I'm not actually starting with my show. I'm just saying, okay, I'm just going to rearrange it so it's a plus. It's the same thing. Like that. And that's to that, right? So then I'm thinking in my head, well, how do I've got to write something up. Here I have a bunch of intersections, and in number 3, I have something with a union in it.
Right.
So I'm thinking, how do I make, and I want the sum to be on the right side and my probability of A to be on the left side. So somehow I've got to get a union involved. There's no union. So it takes a little bit of work to think like this, but I think about it. So once I have this written out, I can just let it gel for a few days and think about it, right? And you get better at it. So it's like boxing class. If I went to your boxing class, your boxing instructor would say, oh my God, she's flailing around like a lunatic,
right,
and she doesn't know how to actually do it. My son already told me that. He's like, you're flailing around. But if someone really shows you how to do it right, and you do it every day, you get good at it. Your boxing instructor is probably pretty good at it.
Yeah.
Okay, so, because he or she's doing it all the time, right? So I'm doing this all the time, so I can see that pattern for at least these proofs quickly. So here's what I thought to my head. I need to write A, because it's on the side that's not with a plus, as some kind of union. And that union has to involve these sets. So the first thing I thought was...
Morgan's?
Well, no, actually, I didn't even think... I thought I might need De Morgan, because that's how you can rewrite sets. But here's what I did. I asked myself, is it true that A is equal to A intersect B? The first thing I asked myself in my head, so this was not in your notes, but in my head, I was asking myself, is this true? Because if that was true, and if these two sets were disjoint, then I can just apply property 3, right? And it turns out, if you draw a Venn diagram, it is true. So I'm going to draw it on your piece of paper. So this is I'm thinking, if I take A and B, I can see that A intersect B complement is this part. It's the moon-shaped part.
Right.
And A intersect B is that football part. They're disjoint. So these two guys here are disjoint. I can see, intuitively, I can see why. I have to still prove that. But I believe it's true. That's why I put claim 1, claim 2, because I think it's true, and then I have to go and actually do the details. Okay? So I looked at the Venn diagram, convinced myself these two sets are disjoint. This is the football part of the intersection, and this is the moon part of the A. And their union does indeed equal A, at least in my diagram. Right? So now I've got a strategy. Because my strategy is, so it's almost like I'm thinking of the proof backwards. I'm thinking, I just pop probability of A on here and a probability of the side on here. Because these are disjoint sets, property 3 allows me to separate them. And then I use high school algebra to solve.
Yeah.
Right? So I got my strategy.
Okay.
Right? So if you go to the solutions, I think my solutions actually are much more developed than I saw my professors doing. But even that preamble that I gave you, like what was in Dr. T's head when she ever came up with this. So I'm thinking De Morgan's laws too, that I have to use that somewhere, because that's the way that you actually prove those little details. So I'm thinking of those details too, but I have the big picture already. And so I knew I could see that I would need these things, but here you see me go for it. probability of A is, I needed somehow to get an intersection involved. That's the, I couldn't just put these B and B complements in there. So I had to think a little bit harder. Like, how do I get the B and B complement to be part of the same equation as A, or inside the same expression of A?
Right.
And so I tinkered around for a bit. That B and B complement actually union up to be the whole sample space.
Okay.
Right? And so I had to prove that back in the claim up there. That's how I got them involved. I got to get them involved. I'm not allowed to start with my show and go forward. I have to start with what I know and go that direction. And so there is no B and B complement if I start with A.
Okay.
So I need to get them into play somehow. So that's what led me to think this. And then I used De Morgan's laws to split these guys up. And now I'm home free. Now I've got the split.
All right.
Right? So it's not the same as cranking a U substitution. It's a different thing. It's like a puzzle with a deadline.
Okay.
Right? So the puzzle's under pressure.
Okay. So I'll go back through that proof that was posted.
Okay.
The solution. And
All right.
I'll see if I can work through 4 then.
And this is not the only way to do it.
Right.
Like, you might come up with a different way to come up with, like, I was, when I was sitting with Eric yesterday, I was thinking, I didn't have to maybe do these 2 claims. That was just the direction I was going.
Yeah.
And I was able to prove those. And I got up to here, and I was like, oh, I can't split these up. There's one more addendum to property 3 that these sets have to be disjoint. And I forgot to prove that. So here's my addendum. I had to prove that they were disjoint. I did that by contradiction.
So what does it mean to do something by contradiction then? In that?
It's hard to show something is empty. It's easier to show something's in there. So when it's easier to show the other direction, I assume the opposite and say it can't happen. So I started out saying, assume that it isn't empty, then there's something in there. Then there's something in both of them. If there's something in both of them, then it's, by definition of intersection, it's in B and B complement. But you can't have B in both.
Right.
That's impossible. So I came up
Okay.
with, right? So,
Okay.
so these little details too, when I first started writing proofs, I didn't have them in there.
Yeah.
And I forgot to, I don't know, like maybe I just said them. There's someone who used to sit next to me, and he had a master's degree from his own country.
Mm-hmm.
And always say, let me see your proof. Like, I just hand my proof to him, and he'd say, you forgot to. And like,
Yeah.
finally, I said, I'm not going to show you my thing. I'd rather just get it wrong. And then, but I mean, he taught me to look out to that for that detail. And it's amazing. I don't have attention to detail on anything else in my life, but when it comes to proofwriting, I have it there. And you'll see it. Like, you don't see it here.